I was dealing with a no start, no crank situation in my 1999 Sanger competition ski boat. This boat has a Mercruiser 350 inboard. It also has the Velvet Drive transmission. Now there were times that I'd be having a great day, no problems, and then the engine would not start, would not turn at all, no clicks, nothing. I would jiggle the throttle control and the boat would finally start. This would only happen a couple times every once in a while, and I just kind of ignored it until one day I was out on the lake with a friend and this thing would not start. This video will demonstrate the steps I took to resolve this issue that led me to another problem with the Mercruiser engine. But you're going to have to stay tuned to the end to see how I could have accelerated the repair process and also saved myself about $40 in parts. Well, sometimes with this Mercruiser inboard, the engine doesn't start with the first key click unless I jiggle the throttle. That probably is an indication of a problem with the neutral safety switch. Here you can see no start condition. Before I move on this video, there is a caution that came to mind as I was watching my prior segment. I want to make sure you understand that every time you turn the key to the off position and back on in a fuel injected vehicle, you're repriming the fuel pump and you might be putting additional fuel in the cylinder. Now the reason that's bad is that you're filling that cylinder up with fuel, which is going to make for a difficult start. You're basically flooding the engine, but also that fuel is going to run down the sides of the cylinders into the oil, into the crankcase, mix with the oil and destroy the oil. What you want to make sure is that if you're trying to start the engine multiple times, leave it in the run position and just turn it to start. Don't turn it off, then back on. It's hard to diagnose a problem if you don't understand system design, so I'm going to take a moment to provide a better visual of how the neutral safety switch and slave solenoid operate. Before I do that, please take a moment to hit that like button, which helps push this video on to other viewers. I always look for wiring diagrams online to assist my diagnosis, and in this case, I searched for 1999 Mercruiser inboard neutral safety switch wiring diagram. My search resulted in this general diagram. The neutral safety switch allows a 12-volt signal to pass to the slave solenoid. When the transmission selector is in neutral, a 12-volt signal is delivered to the slave solenoid, which then provides 12 volts to the starter solenoid, allowing you to start the engine. Since I suspected the neutral safety switch as the cause of the no-start problem, my first test will confirm operation of the switch. I'll use a multimeter to test resistance across these points. I should have zero resistance in neutral and open line or infinite resistance when the throttle selector is in gear. Here you can see the neutral safety switch on the Velvet Drive transmission. I've got my alligator clips on my ohm meter attached to it. So how I'm going to test this is to run the throttle transmission selector back and forth to make sure that that switch, the neutral safety switch, is working. So as I pull it back, I should get a loss of continuity, which I did. It's only 4,000 ohms, but you can see how far I had to pull it back for reverse. Now let's go forward. Same thing, very little. But now it's taken much more throttle position to do that. So what this is telling me is probably that neutral safety switch, or at least the transmission selector at the Velvet Drive, is not centered. So I need to adjust that. Yeah, it goes directly to higher resistance and forward. It takes quite a bit of time to go in reverse. So let's center this. So once again, here's the neutral safety switch on the other side of this Velvet Drive transmission. And this is the transmission linkage that puts it in forward and reverse. When this linkage goes backwards, that's what puts the transmission in reverse. So I need to disconnect this and adjust it on these threads to get it into the proper centering. What I had to do was adjust this rod. I had to lengthen it. Now, in order to do this properly, you need to disconnect this nut, just take this nut off, take the cable off, and center this thing. There's a little notch in there, so you'll feel the notch. You can test it with your ohm meter to make sure you're dead center and you've got continuity. Once that's centered, then what you need to do is adjust the length of this rod to meet up with that hole perfectly. I had to lengthen it about, I think it was about 1.5 to maybe 2 turns, and I got it dead center here. So now I tested it with the ohm meter. It's perfect, it's dead center, and now all I got to do is test it by actually starting the boat. Even though I adjusted the linkage to center on the neutral safety switch, I'm still having some problems with this thing starting from time to time. Not as bad as it was, but still a problem. I went ahead and bought a neutral safety switch to replace this. It takes a 7/8 socket, and you can remove the neutral safety switch without worrying about transmission fluid coming out of the opening. I bench tested the old switch against the new switch. The old switch shows OL, or open line, when the ball is depressed into the socket and shows good continuity when the ball is released. Similarly, the new switch has the exact same performance. This test demonstrates no difference between the two switches. Given the old neutral safety switch test the same as the new one, I can only consider that maybe these contacts were dirty or corroded when I broke them loose. It's now giving me good continuity through the mirror. The only other thing I've noticed is that the spring holding this ball in place is not quite as strong as on the new one. So I'm going to go ahead and put the new one on since I bought it relatively cheap. I've linked it below for you. But I'm going to clean this up and keep it as a backup. But what you can do yourself is to pull this off, clean these contacts real good, use sandpaper on the wiring lugs, reinstall it and see if that helps you out. If it doesn't, again, I've got the link below for the new one. You can switch it out and see if that helps. Even after replacing the neutral safety switch, I still had trouble. The intermittent trouble now has become continuous trouble. I can't get it started at all. Now on to the second test. Since I know the neutral safety switch is good, it might be the wiring. I'll check the wiring to and from the switch to make sure there are no breaks in the wiring and it's providing proper signal. Next, I'll move on to the slave solenoid. To test the slave solenoid, I'll set the multimeter to DC volts and find the lug with 12 volts while the ignition key is off. I'll connect my meter to the other lug. When turning the key to the start position, I should get 12 volts and activation of the starter motor. If 12 volts does not appear, there's a high probability that the slave solenoid is bad and needs to be replaced. With a brand new neutral safety switch, this is the wiring harness coming from it. I've checked continuity on here, it's good. I can hear the solenoid clicking when I try to start the engine. This is the slave solenoid and this is the circuit breaker. I've got 12 volts on each side of the circuit breaker, but I only get 12 volts on one side of the slave solenoid when I try to start the engine. I jumpered these two lugs and was able to start the engine, indicating the slave solenoid is bad. I ordered a slave solenoid from Amazon that I'll link in the description of this video. I've got my new slave solenoid in hand. I'm going to go ahead and replace the unit here, but the first thing you need to do is disconnect the battery. All right, everything's buttoned up and I used a lot of dielectric grease to make sure there's no corrosion. And to do a quick test, well, that tells me that I've got slave and starter solenoid working properly, so now it's time to take the boat out for a ride. Okay, now with the boat running, the repair is complete, everything's resolved, here are my learnings. The neutral safety switch. When I was doing the testing with the ohm meter, pulling the gear shift lever backward and forward, I should have paid more attention to what those meter readings should tell me. Number one, in neutral, I should have full continuity, no resistance whatsoever through the switch. And when I pulled it into gear, both reverse and forward, it should have given me open line. I should have had no continuity whatsoever, but if you recall, I was getting a lower resistance, which is not good. So what I should have done was pulled this, cleaned the contacts, as I indicated earlier in the video, cleaned the lugs to the wiring, put it back on, tested it, and see if that improved the operation. I actually feel pretty sure that this was not a fail point. It maybe had some corrosion on it. I mean, this is a 23-year-old boat used in water. I think if I had reinstalled this, it would have worked and I would have saved myself $40, which was the most expensive part of this repair. Now, on the other hand, the slave solenoid, which actually gives signal down to the starter solenoid on the starter motor, this did fail. It was a 100% absolute failure after I replaced the neutral safety switch. I was getting 12 volts on one side, as I showed in the video, but I was not getting 12 volts on the other side when I gave it a key click. I jumpered these two and it actually started the motor. So this was the actual problem. This was a $20 item delivered from Amazon. I'll link all these parts below, but this could have saved me a considerable amount of money in terms of overall percentage of cost if I had just really focused on what the real problem was. So obviously I'm making a mistake, so you don't have to. I hope this video helped you, and for that reason, please give me that thumbs up, please comment below, please subscribe. I'll see you next time on Driving Intelligence.